All right, we forgot to record, and so here we are. We just said that this times this equals this. That's what we talked about last time. There is a similar formula for division. Okay, dividing two things is the same as, so multiplying two square roots gives you, or multiplying two roots gives you the root of what you multiply. Dividing two roots gives you the root of what you divide. It's really because of this same principle right here. And we talked briefly about why this right here is this right there. It's the only way it could be with that one in the numerator. But anyway, that's what we're going to be working with in class. Can I erase some stuff?
Yes.
All right. Okay, so how does this thing come into play? Let me go ahead and write it down here because this will be one of our central, this will be our central equation for this class. And that's any root, right? The nth root, the kth root of this stuff. Well, one way that you're going to see it is if you have, let's do this one. This is the square root of 49 over y squared. Well, right here, we just take this and say, well, first off, what I always like to do is say, does anything cancel here? Like, can I go ahead and simplify this out? Like, for instance, if it were 100 over 2y squared, I would say, well, hold up, I could simplify this because 100 is just 2 times 50. And that's over 2 times y squared. And so I could go ahead and cancel out those 2's and make what's in there even simpler to begin with. But in this case, no, nothing's going to cancel out. That's like a 7 times a 7, I think, and a y times a y. Those things don't cancel out. So I'm going to go ahead and apply this right here and say, well, this means the same thing as the square root of the top over the square root of the bottom. And what is the square root of the top?
Hold up. Square root. Wait, are you asking me to simplify it?
I'm just asking you what the square root of 49 is. It's one of those you should just know.
7.
Yeah, 7. There you go. 7s and 8s are the hardest for me. I can't multiply something by 7. I don't know. It's a hard one for me. But yeah, because 7 times 7 is 49. So the square root of 49 is 7. So what about the bottom? How do we simplify that guy?
The square root of y squared is just y, isn't it?
Absolute value of y.
I have a question. For square roots, if you have like a cubed root of y cubed, isn't it just going to be y?
It will just be y because it's an
like you can
odd root. The odd roots come out to be whatever they are.
I feel like when you have like the same, what is it called? Exponent?
Yeah, the same exponent, the same number exponent, and the same number root. Right.
Is that always going to be the case? Or?
Yeah. Basically, they're inverses of each other, right?
Okay.
Because you're saying you took a number and you cubed it. Okay, so like we're imagining in this case, you have the cube function. You took a number and you cubed it, and you got this guy out. And so then when you pull him back, in other words, when you take the cube root, you're just saying, well, it should just come right back to where you came from. And yes, that's true with cube roots, because if
your camera went out.
Were a negative number, oh yeah, of course it did. Of course it did. That's it. We're done. We're done with this. So, good question. I'm glad you're asking this. This is because you need to hear this like 3 or 4, you need to see it 3 or 4 times before it really sticks in there. So let's take a look at this. All right, that looks good. So let's talk about why it's different with even and odd roots. When you cube, and your intuition is good, like you feel like if you have the same number here, it should just undo what you did. And so when it's here, we're graphing y equals x cubed, and you take a number, let's call it a, and we plug it in, we cube it, that gives me a cubed. So then when I undo this, it should bring me back to a. That is, when I take the cube root of the thing I got, which is a cubed, it should bring me back to a. And you're absolutely right to say that. Now, let's do a couple examples here why this is the case. Let's say I plugged in a 2. What is 2 cubed?
16. Wait,
Nope.
2 times 2 is 4 times 2. Oh, whoops, 8.
8, good. Okay, so we get 8. And so then we say, okay, yes, if I took the cube root of 8, well, just by definition, that's what it means. It brings me back to 2. And we can kind of see this, and this is where your intuition is absolutely correct. You're saying, I feel like if I have something like this, I have a number that I cube it and then I uncube it, it brings me back to whatever that number is. And so that's why we should have this formula, a cubed, the cube root of it brings you back to a. And this is why this always works with odd roots, because let's see what happens when I take a -2 and cube it. What is -2 cubed?
8. Well, minus 8.
Minus,
Yeah.
right? And so now let's just look at this. -2, -2, -2 gives me +4 times -2 is a -8. Okay, so now check this out. -8 is the number. So in other words, -2 cubed is -8. That's the thing. Now, therefore, right, when you plug in a -8 into there, the cube root of -8 is the same thing as the cube root of -2 cubed. You do get -2 as where it came from. So to see this in pictures, we took -2, we plugged it in, we got out a -8, which is the same thing as -2 cubed. And so let's look at this picture. You're taking a number, -2 cubed. -2 is the a right there, right? There's the a. You have a raised to the third, the cube root of it, you pull it back, and a is the number that you get back. That is a, and that guy is a. And so this is your intuition, right? And you're absolutely right to say that. It's like, it's always going to be whatever I plug in, that's what's going to come out. Watch what happens when we talk about an even. So now we're going to take a number and we're going to square it and see what happens. Let's take +2 and square it. What's +2 squared?
4.
It is 4. And so we could say the square root of 4 is equal to the square root of 2 squared, which comes right back to 2. And in this case, we could say, yeah, you plugged in this number, you squared it, you got out 2 squared. And so then when you pull it back, you end up right exactly where you started. It's at 2.
Why isn't it the absolute value of 2?
It's 2 because we're dealing with actual numbers here. We knew in this case, 49 in this case was a positive 49. And so we knew that positive 49, give me just a second. This is a good question. And we're going to get into that in just a second. The reason, so watch, you piece. Man, okay. It was, man, yeah, he knew that GRANDMA, which I'm not going to say, called, and he was, it's Kayla.
Peter.
So now watch what happens. Plug in a -2. What do we get when we plug in a -2? What's -2 squared?
4.
Positive 4. Okay, so now watch this.
Please.
Oh.
I'm sorry, buddy. We gotta wait. So now, when we take the square root of -2 squared, right? That's the same thing as the square root of 4, which is, by the way we've defined this right here, we said it's always going to pull back the positive number. That's always going to give you a positive 2 when you plug in an actual number right there. This number gets squared, and so it's no longer a negative, and so we can undo this thing and end up with a 2. And so regardless of whatever you plugged in here, right, when that is your input, once you square it, it becomes positive 4. Once you square this, it becomes positive 4. And just by definition, when you take a positive number and you take its square root, by definition, you get the positive number back out. That's how we define this, right? We always talk about this as the principal square root.
Mm-hmm.
Since that's the case, it doesn't matter whether you plugged in a positive or a negative here. The thing that comes out is a positive number. And so now finally, let's take a look at that. So we're saying you take the square root of a number A squared, and it doesn't matter whether A was a positive number or a negative number. We ended up with not A, right? In this case, it happened to be the case that we plugged in a positive number, and so it stays positive. Yes, that's just like this. We had a positive 49, and so now when we pull it out, we have a positive 7, of course. But in this case, that number right there is a negative number. And so we can't just say, oh, you had a negative number, so that is your output. No, we know that that has to be a positive number. So when it has to be the absolute value of it, because let's just look at this. If, let's pretend for a second, I'm going to get rid of all this cube stuff here. Now you see in the cube case though, if that number happened to be a negative number, right? When you cube it, you end up getting a negative number, and that's perfectly fine because when you pull it back, you could have a negative number. So if A, in this case, were a negative number, right? Like we said here, A is a negative number. The answer will also be a negative number. Whatever A is stays negative. In this case, whatever A is, whether it's positive or negative, comes out to be positive. And so I'm going to erase this stuff. So for instance, let's suppose that it weren't like this. So I'm going to do it in red because what I'm about to write is not correct. We have a square root of some number squared, and let's suppose that it came out to be that number right there. If that were true, then when I plug in a number, no matter what number I plug in should work out here as well. If I plugged in a -2 here in this wrong formula, the formula that's not true, if it were just whatever that was, then I would have to do this right here. I would say, well, whatever goes in there is also going to be right there. And then I'd say, okay, we take the square root of, what's -2 squared?
4.
4. By definition, we're taking the square root of something, we're taking the principal square root. And so the principal square root of 4 is what?
2.
+2. And so we have a +2 right there. And it is not the case that +2 equals -2. This is not true. That's why I did it in red, because this is not the correct formula. What is correct is this guy right here. And let's just really drive this point home by doing this. I'm going to say, what is true is that the square root of something square, yes, you're undoing it, and so you should just get back to where you came from. But the problem is when you square a negative number, you get a positive number. So let's just double check that this works. Instead, so now this formula says wherever I write in an A, whatever I write in for A here, I have to write it right there. So when I do a -2, I have to do a -2 here. And now we're going to do the same kind of thing. What is -2 squared?
4.
+4. What is, and this is just the absolute value of -2. Okay. What is the absolute value of -2?
2.
And what is the principal square root of 4?
2.
2. So the problem is from this right here, is that whenever you square a negative, or you take a negative to the 4th power, or to the 6th power, or to the 8th power, any even power, it turns it into a positive. And so if your formula said, well, you just, whatever number that happens to be, you just write it right there, you're going to run into something like this. Because if you happen to plug in a negative number, well, once you square it, or take it to the 4th or to the 6th or any even power, you no longer have a negative number. And then since we're always dealing with the principal root, when you do this, you'll always end up with a positive number. But if your input was negative, if you just plugged it in here, you would end up with junk right here. And so the way around it is to say, okay, whenever I'm pulling something out of a even numbered root, I have to consider its absolute value. Why? Well, because you can't have a negative coming out of a even number root, because everything that you plug in gives you a positive answer. Does that make some sense?
Yeah.
It's difficult. It's a hard one to get. And I remember when I was learning this, at first I just memorized it. I was like, okay, what? I don't get it. And I guess whenever I have an even number root, if I have variables, and this is where it gets really tricky, because right here you said, well, then why isn't this the absolute value of 7? And it's because we know that 49 is positive. We don't know whether or not y is positive, right? Y might be -2, in which case, so let's do this. It might be the case that y equals -2. And let's just say, so we have two ways of doing this. We said that this reduces down to this. Let's say that we did it this way, 49 over y squared. And we said, you know what? I think it should just be y, because the square root of y squared should just be whatever y is. So on one hand, we could take this and say, okay, if this one's true, we'll have something like this. Wherever I see a y, I simply replace it with a -2. So this formula would tell me that I replace this with the -2, and I have that. This one says that wherever I see a y, I replace it with whatever y is. And so we have 49 over something squared equals whatever that something is. And if I plugged in a -2 right here, I would have to, this formula would say plug in a -2 right here. And so on the left-hand side, we have -49 over, 49 over -2 squared is +4. And so I'd say that's the same thing as root 49 over root 4, which should be 7 over 2. And that is what we get with this right here, which is what we said the answer was. So that agrees with that formula. But if I tried it over here, we would see, okay, 49 over this gives me 49. -2 squared is 4, which is root 49 over root 4, which is 7 over +2. But this formula tells me that it's 7 over -2. Uh-oh, that can't be. You can't take a square root and get a negative number. And so this formula does not work. That's why it doesn't work, because once you've done this type of thing, if it were negative in the first place, then when it comes out, it's got to be positive. Because once you do this, you forget. It forgets that it was negative to begin with. Whereas this, you're saying, yeah, it'll remember that it's negative. No, it won't. It's going to forget that it was ever a negative number. So no matter what comes out of here has to be a positive number. Does that clear it up a little bit?
Uh-huh.
So it's something you got to just remember right now, but it's consistent. And if you doubt it, just plug in some values. And we can see that, yeah, once you do this, we have no recollection that that was ever negative to begin with once you square it. And so there you go. Okay, so this is one of the things you're going to have to do. And it's an application of this formula right here. Another thing we're going to have to do is, let's do this. There's going to be more difficult ones. We'll do these two. There's some more difficult ones. Here's a more difficult one. So that's one way of doing it, where you have a root and something in it. You ask, we didn't do this, but can we cancel anything out to begin with? Okay, and then we go and split it up and stuff like that. Just like in your last homework, we're going to do it the other way too. They're going to give you something split up and see if we could reduce it or what we could do. So here's one, 75ab, square root of 75ab over 3 times the square root of 3. Now, here's the trick. There's a little trick here, is we have this out front. And what we could do is anytime, and no matter what you have, if you have a 3 out front, and maybe let's say we had a 2 up here or something like that, we could just take whatever those constants are and write them out front like this. So that's kind of step one, is like, just forget about these guys until the end. Like we'll bring them back in later, but right now we're gonna forget about them. And now we're gonna use this formula and say, that's the square root of something over the square root of something. That is the same thing as the big old square root, like that.
No way. No way.
Now the hope is that these things can cancel out, that something cancels out. What's 75 divided by 3? Is that doable? I think it is divisible by that. What I think about is 75 cents is how many quarters? 3 quarters. And after being a cashier, you're gonna be really good at that. Like, oh yeah, 3 quarter. Like you're gonna see that and immediately have the image in your head of 3 quarters. And the longer you're a barista, you're gonna know exactly how heavy that is too. But anyway, that is 3 times 25 times AB. And so we can cancel out this 3 right here and right here. And now we have 1/3 times the square root of, well, now we don't have anything in the denominator. We're good to go. We have 25 AB. And so this should kind of harken back to our last homework, right?
Yeah.
What can I pull out of this right here? How can I rewrite that?
Okay, so you take 1. You can take a 5 squared out of it, right?
Yes, 5 squared. 25 is 5 squared. And so it comes out as what?
Just 5.
Just 5. There we go. Right. And then what's left over, I guess it's just the A and the B. So there's the A and the B. Technically, we're done. It would look a little slicker to group all of the constant terms together. And so we have a 5 in the numerator, a 3 in the denominator, and I could write this as 5/3 times the square root of AB, which is the same thing as 5 root AB over 3. You can write these any way you want. I have no preference over which way you write this. In fact, if you wanted to leave it like that, that's cool too, but it's good to get into the habit of grouping all your constants together, especially when dealing with something like this. I mean, imagine for a second that you had 1/3 times 5x. You'd say, well, if I needed to write that in terms of x, I would write that as 5/3 x. And so we're kind of thinking about whatever's left in the square root, or any root for that matter. We kind of think about that as just like a variable in and of itself and ask, well, how would I write that? Well, I'd probably combine those terms and just call that 5/3. And so I'd have 5/3 x. And so it looks like that. But that's also the same thing as 5x over 3. And so if you had written it like that, that's cool too. It's just, I'd prefer to not see it like this. I'd want to see one of these guys. That would be cool. So does that make sense what we're doing there?
Yeah.
Okay. Now, this is going to be, of these types of ones, this is going to be the most difficult type, where you have something like this. They are using that right there. Yep. Let's do x's and y's. X cubed plus y cubed over square root of x plus y. Oh man. Oh, dude. Well, I'm not quite sure what to do, but I have this nifty formula up on the board. Excuse me. Maybe that'll help me out a little bit. So I'm just going to rewrite this guy because they're both square roots. So I could combine them and say, well, that's the same thing as the square root of the quotient. Quotient of square roots is the square root of a quotient. Okay. What does your intuition tell you that we should do with this bad boy?
So where are you to?
All right. Because the name of the game right now is see if something cancels, right? Just like with the last one, we had 75/3. And it was like, well, maybe something's going to cancel. It'd be cool if it did. And so now it's like, well, what could I do to that numerator to hope that something might cancel?
Factor it out.
Factor it out. And how do we factor the sum of two cubes?
Okay. That's the weird soap thing, right?
It's the soap thing. Yep. That's exactly what it is.
So
Oh.
hold on.
Okay.
Right. So X and Y.
X and Y. Yep.
So you don't want me to do the signs yet, right?
Let's wait. I think it's easier to do the signs at the very end.
Okay. So then X squared.
Yes.
X, Y.
X, Y. There you go.
And then Y squared.
Y squared. There it is. Now let's do the signs.
So same opposite. Positive. So plus, minus, plus.
There we go. Now, does something cancel out?
Yeah.
Yeah. And immediately I noticed that, right? Because I was like, wait a minute, sum of two cubes. And I already knew that the first thing looks like this. And so, yeah, I felt good with going along right there because I knew, that's gonna do that. And so now let's see. Well, there's no denominator anymore. So, okay. I guess we have just whatever is left in the numerator. That thing does not factor out. And I think we talked about that in class. Once you're down to here with a cube formula, right? The formula for cubes, either sum or difference of cubes, this thing does not factor. He is completely factored.
Right.
And so we know he's completely factored, so we're done. We can't do anything about that. This does not, addition and subtraction don't split up a square, right? Like we could do this, X, Y gets split up into X and Y, but it is not the case that X plus Y break up into, I don't know, X plus Y. That does not happen. And so we're done. That guy is as factored as he's going to get. And that is the answer. That is how we simplify that guy. So you're going to see those types of questions. Okay. Now, the last thing that we need to talk about. Oh, I've just started erasing. Were you done?
Yeah.
Okay, great. Okay. Now, the last thing we need to talk about for the homework, we no longer need this guy right here. We are done with this guy. So if I gave you this and told you to simplify or combine like terms or whatever, what would you write?
17x.
17x, right? Because honestly, what goes through my head is, well, if I have 8 apples and I add that to 9 apples, I got 17 apples. Like, honestly, that's what goes through my head. It's like, yeah, 8 apples, 9 apples, 17 apples, right? There's no difference between apples and oranges, okay? If you have 8 apples and 9 apples, you have 17 apples. If you have 8 oranges and 9 oranges, you have a total of 17 oranges. It just looks funky, right? And so you're going to have some questions like this, really simple, like it's straight. This is one out of the book. It's an even one, so you don't have it, but there's a bunch like this. And the same thing is true if it's I don't know, how about 7 times the 5th root of, I don't know, 3. And we go minus 2 times the 5th root of 3. We could say, well, 7 apples minus 2 apples gives me 5 apples. It's just that apples happen to look like this thing here. And so there's no tricks with that. That's all you're doing with these. But then it gets a little bit more difficult and you get stuff like this. Can I erase this stuff?
Yeah.
Okay. Okay. All right. Which one did I want to do? That's a good one. So here's this. And you say, wait a second, 2 oranges plus 5 apples. You can't add apples and oranges, man. And then the question is, well, how do you turn apples into oranges? Because maybe I could rearrange this thing to look like this thing, or vice versa, right? But what I'm seeing is that I know that 12 is something times some other stuff. And so maybe, I don't know, maybe we could reduce this thing to look like this thing. And so when I look at that, I'm like, well, okay, I'm just going to break it down. 12 is what times what and blah, 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 blah. Okay, so just going back, you might have heard whatever part of this you might have heard. I'm just going to do my spiel again. Here we have 2 oranges and 5 apples, and you say, you can't add apples and oranges, silly. And then I say, well, maybe we could turn oranges into apples, right? Maybe I could rewrite this thing to look like that thing, or vice versa. I'm not sure which way to go, but I do notice that 3 is prime and 12 ain't prime. What is 12? 12 is what?
6 times 2, or 12 times 1, 6 times 2, and 3 times 4.
There we go. And so I'm going to say, you said 3 times 4, which is what this is, right? 2 times 2, 3.
Yeah, sorry.
Just like that. So I'm just going to rewrite it like 2 squared times 3. So, and as I'm doing this, I'm thinking, well, wait, 12 is a positive number. I don't need to worry about absolute values or anything like that because it gave me an actual number. And so, oh, nice. And another thing, like as I'm doing this, the hope is that this thing is going to turn into this thing. And so I'm thinking, well, can I get a 3 out of there? Can I get a 3 all by himself with this factorization? Yeah, I can. And so this helps, right? And so this is 5 square root 3. What does that reduce down to?
4 square root 3, right?
Right. And so we still have a 2 out there. So the 2 comes along for the ride. And then we had, just like you said, 4 root 3. 2 times 4 is what?
Hold on. 3 plus 5. 2 times 4. 8.
There we go. So we have 8 apples plus 5 apples. Gives me how many apples?
13 apples.
I think 13. 13. And so the only difference is it's not an apple, it's a square root of 3.
Right.
Okay. So that's the idea with these. And with all of these, they're gonna give you a bunch of different roots. It might be a 3rd root, it might be a 5th root, 4th root, whatever. But the idea is, can I turn them all into the same type of root? these will look really ugly. Actually, let's not do that one. I wanted to do that one. Let's do a tough one. So
Wait.
uh-huh.
Oh, no, never mind.
Okay. You sure?
I was wondering how you got the 13, but then I realized that, yeah, never mind.
Okay.
We're good.
Cool. So, okay, we're gonna do a more difficult one, and then we're gonna do like the most difficult one.
Real quick.
Yes.
I do have a class at 12.
Okay, this won't take long. This won't take long. I just want to. This is what you're gonna need for the homework, but we'll be done soon. So here's a difficult one. 9 times the cube root of 16 x to the 5th minus 2. Again, cube roots. So I'm seeing, we have cube roots. And so cube roots are the sort of thing that I could combine. Can't combine a square root and a cube root, but with 2 cube roots, you could totally do that. And so we have squared and a y. So cube roots, so I don't need to worry about absolute values. But what I'm going to do is hope that, so one thing I noticed is we have a y and a y. So the y's are good. You don't have enough y's to pull anything out. So forget it. Here we have an x squared. Not enough x's to pull anything out because we would need 3 x's. We don't have 3 x's. So xy is going to be what I'm going to try to do with this guy over here. Same way before when we had 12 and we knew that we had a root 3, I could think, well, 12, can I write that as 3 times something? And indeed, we could write it as 3 times 4. And so it's the idea. I'm trying to get these guys to look the same. And so I'm going to say, okay, how about I rewrite, and I chose to do the variables first. There's no reason necessarily I needed to do that, but I could rewrite this guy in this way. I could have done the numbers first. I just chose to go with the variables for whatever reason. Now I can see, okay, I'll definitely be left with an xy over here, or x squared y. We also have an x squared y over there. And hey, lo and behold, what do you know? That's exactly what I need to pull out 1x from here. So I'm going to do that. I'm going to say the x comes out not as an absolute value because it happens to be to the 3rd, or it happens to be a cube root. And now we have 16x squared y. So the oranges are starting to look a little bit more like apples. Right? At least we got the variable parts being the same, which is cool. And now what can we do? Well, 16, I guess we could factor it out, and 128, hopefully we could factor it out as well. 16 is 2 to the 4th, I believe. 2 times 2 is 4. 2 times 2 is 4. Yes.
Are you still going to write the cubes over the other roots?
Yes. Yes. Thank you. Excellent. Good catch. You get a smiley face. Good job. Awesome. Okay, good catch. So let's factor the numbers. And I know that they're both powers of 2. So
you can take a 2 out of the 16.
Yes, we can. And I'm going to be explicit about that here. I'm going to write that as 2 to the 3rd times 2.
Mm-hmm.
And with the 128, I believe that's the power of 2. It's 2 to the 6th.
To the 6th.
I think. Yeah.
Mm-hmm.
Which is 2 to the 3rd times 2 to the 3rd. But you could do this however you want. I can see I get to pull one of these bad boys out. And so a 1, 2 comes out. So that gives me 2 times 9 times 2. Yeah.
I think.
Oh.
It's to the 7th.
To the 7th. You're right. You're right. Because yeah, 2 to the 3rd is 8. 8 times 8 is not enough. We need 1 more. Good catch. Man, you get a smiley and a star. Man, you're blowing it away today. Good catch. Thank you. So, and that would be one thing that I would check as I started doing this. If it were if we didn't have my 7 2s there, I would have pulled that out. I would have had a 2 left over in here, no 2s left over in here, and I would have apples and oranges. I wouldn't have the same thing. So that would be, okay. So I get a pull from over here, I get a pull out 1 2, leaving me a 2, an x squared, and a y. Here, it looks like I get a pull out 1. So I'm going to write my first 2. Pull out the 1 2, pull out another 2. Those guys are gone. And now I am left with 2x squared y. So I have 18 that. Now this is ugly. I don't have an x cubed over here. So I have 8.
Wait, where'd you get the x cubed?
It's not an x cubed. I can't read my own writing. That is an x, the cube root. Yikes. It's a cube root. 2 times 2 times 2 is 8. And that should be root. Okay. Cube root. All right, you following thus far? I think I did it right this time. I think we got everything. Okay.
Yes.
Okay. So I'm going to erase the top. Give me some more room here. Now we have 18x times the cube root of 2x squared y minus 8 times cube root of 2x squared y. And just like before, right? If I had something like 18xy minus 8y, I'd be able to factor out a y from that, right? So it's the same kind of thing here. I'm going to say, well, I could factor this thing out of this expression. And in practice, we usually put the roots on the far right-hand side because it looks nicer. And so when I do that, I'm going to pull that root out this way, and I get my cube root of 2x squared y comes out. What's left over? Well, 18x minus 8. And I noticed that I could still factor something out if I wanted to. You could leave it like this, but it's really cool to have everything completely factored. And there's a 2 in here and a 2 in here. So I'm going to factor out a 2 and say, okay, that's the same as 9x minus 4. And that's probably how you would see these in the back of the book. This is probably the way that they're going to be given. Usually, we like to have everything as factored as possible. And so, there's that guy right there. The last thing we need to talk about in order to be able to do your homework is number 52, which is a doozy. So, do you got all this? Can I erase this?
Yep.
Number 52. Root 4x minus 4 minus x cubed minus x squared.
Yes.
Okay, here's the thing. This doesn't look like, these don't look like apples and oranges. This looks like, I don't know, sandwiches and a book. Like, these look nothing alike. But what I notice is that there's a common factor here, right? And so I'm just going to start with the simpler looking thing and factor out the common factor. There's a 4 in there, there's a 4 in there. So I'm going to rewrite it as 4 times x minus 1. 4 happens to have a square root. So I could make that even easier and rewrite that as 2 times x minus 1. Now what I notice is, hey, there's also a common factor in here, and if I were to factor this guy out, and you're doing this with all of these, you're kind of looking for commonalities between the two. Hey, they're separated by a minus sign. Hey, if I pull something out, I could get the same thing here. And so if I factored out, say, I guess an x squared, what I would be left with is an x minus 1. And hey, look at that. That is the same thing as that. I can get apples and oranges to be apples and apples. So this is a square root, an even root. So how do I pull out that x squared? Are you there? Are you frozen?
Sorry, I got interrupted. I'm sorry.
That's cool. That's cool. So this is an even numbered root. So when I pull him out, I have to do what?
Do absolute value.
Absolute value of what?
X.
Just x. Okay, now we're kind of back in the same situation. You have 2y minus something y. We could pull out that y, and I'd be left with this right here. And like I was saying, the roots we usually write on the right-hand side because it looks nice. And what's left over is minus absolute x, like that. And that will help you with the last problem. And the one before it also. This is the same kind of game, really. So, you could do it that way. There's a few ways of doing that one. So, okay, let's talk about homework. We're not going to split it into parts this time, like this is like brand new. I'm just springing this on you. So everything will be due on Monday.
Okay.
Yeah. So, okay. We'll just do it all in one fell swoop. So homework. This is chapter 7, section 3. Let's do the reading. Read 7-4 as part of your homework. And remember, you're reading just for familiarity. You're not looking for mastery. Just want to be familiar with what we're going to talk about. The assignment from chapter 7, section 3 on page 30. We're only going to do 303. From page 303. Numbers 3, 5, 7, 9. 3, 5, 7, 9. 17, 11, 13, 17, 19, 21, 19, 21. Are those? Yeah, we're skipping that one. So I do need to write these out. Sorry, I just want to make sure I can't do that. It can't be easy here. Okay, so 25, 31, 33, 35. 37, 41. A lot of these are real simple. A lot of them are very simple. And yeah, so anyway, let's see, 41. $45, $47, $49, $51. I believe that's it.